What is up, people? How's it going? This is Bharat and welcome back to yet another video with the KivyMD OpenCV series. So this video, I'm going to be sharing with you guys how you can create your own photo app filter and probably integrate it into your Kivy application. It's going to be an interesting set of video because we're going to be looking into doing something on the fly, rendering images into video on the fly using CV2 functions, and it's going to be very, very interesting. So make sure to watch it till the end and let me know what you guys think in the comment section below. Today's video is sponsored by Embold.io. Embold.io is an AI-powered static analysis tool that runs through your code package and finds out all the issues. Not only that, it also gives you 8 different metrics that you can improve your code upon, and is a very, very, very useful tool if you're going to be managing a big package. I'm going to be using this Embold.io in our current package in this video, so make sure to stick till the end and watch me work with this Embold.static.io tool, and you will be able to see how amazingly useful it is that you can also use in your project. If that is getting you excited, make sure to check the first link in the description where they have a very good free tier package that you can get started with today. Alright, so a quick recap into what we have been doing in the first two videos. We have created a very simple Kivy application and we have integrated it with PyTesseract as well as CV2. What we're trying to do as part of this video is to take our image or the real-time video that we are going to be playing, and we're going to be making sure to apply a filter on top of that. So what do we need for that? First of all, I'll just quickly run this application so we know what we are actually having in our hands right now. And here is the application. So just a very simple application running on KivyMD. So you can see that I have a camera right here and you guys can see it as well. So this camera basically will be actually handling all my input camera functions. So what I'm going to be doing right now is to take this input and probably also look into making or applying some kind of a filter on top of that. So we need to understand a very simple basic understanding, or we need to have a basic understanding of what does a CV2 do. CV2 has multiple different functionalities. Basically, it starts with applying a background scale on top of that, a grayscale on top of that. You can apply multiple different functionalities to an image. So what we are currently doing is we are breaking a complete image, or we continuously getting image from my input camera, and we are actually loading it and looking it or making it look like a video. So what you're going to be doing is this method is now going to be changed, and you're going to be, instead of just leaving it as a BGR, which is like blue, green and red, you're going to convert it into grayscale and apply a function called as a canny function. The canny is an edge detection function, and it's going to be very, very interesting to look at the output. So what I've also done is done a quick clone of this into a very another file, which is called as the photo filter file. So this is the main application that we have. I've actually made a copy of that into my photo filter file, and I'm going to be applying or writing my code on top of this. So let's go and start working on it. The first thing that we need to do is basically to understand what is going to be the basic application or the pre-processing for the image. The first thing, like I told in the previous video, is to always process your image. Your image is going to be full of noise. If you want to actually get a very good, or if you want to do a very good CV application, which is basically the computer vision application, you need to understand how you can effectively process your video or your input data. So for this one, we already have a frame captured that is going to continuously be running via the video capture method. And what you're going to do now is, instead of just assigning it to a frame, we're going to apply a simple method. Let's call this method as grayscale method. So it's going to be a grayscale methd. I'm just going to say cv2.cvt color, and I'm just going to say the frame is now going to be converted into cv2 color BGR to gray. Now convert it to grayscale image, and what you need to do next is to, instead of just applying or converting it to buffer, instead of converting the frame to buffer, we'll try to convert the grayscale to buffer, or the grayscale numpy array to buffer. So you just can replace it here and change this here as well, and we are pretty much done. So this should be done, right? But you can understand that we are actually in Kivy in particular. You need to be able to create a texture. Now the texture takes the method, which is the create method, and it takes something called the color format, which I told you in the previous video. If you go inside, the color format is basically an integer that is going to be handling the input bytes. So if you want to change the color format, it will be RGBA or RGB, and there are additional things like luminescence and luminescence alpha, and also things like red and RG. So these are basically integer values that are going to be handling or converting our byte data into an equivalent texture data. So for the background or the grayscale that we just created right now, we cannot give BGR. If you give BGR, it's not going to work because the bytes are different, right? BGR has blue, green and red information. But what we have done is we have converted that to grayscale, which will only have either a black or a white, and also on top of that the opacity and also the brightness. So if it is a very intense black, it will become a dark black. If it's a okayish black, it will become gray, and that's how you are going to be handling the grayscale, right? So what you need to do, instead of BGR here, just replace it with luminescence. I am really confused with the spelling. Luminance, sorry. Luminance. Right, so color format is going to be luminance, and the similar color format here should also be luminance. So that's what blit buffer also does. Blit buffer is basically continuously replacing the texture, and this luminescence will be for this right here. So color format also takes luminescence and luminescence alpha, and we are actually going to be keeping it as color format as luminescence. Now this this blit buffer will automatically convert our buffer into the u byte that the texture takes, and we are actually replacing it back to the texture. Now if you run your application right now, you will have a grayscale image. That is what we expected, right? All right, so this is the application right here. I'm going to be now showing you a grayscale image. Now this is the grayscale image completely running on a grayscale, and you can see my face as well. Hello, how's it going? And this is very cool. It's looking cool. Now all you need to do is write a method on top of that, a function on top of that, and with a button click you can change your CV2, and you can apply your CV2 or pre-processing on top of it and start rendering that as your load video inside your load video method. Alright, so this is cool. You can even play with other functionalities like color BGR to RGB, BGR to HLS, and all of this will have its own data that's going to be created. And depending on what you're using here, make sure to also change your texture, and it basically you can just go inside it and find what is the applicable texture. BGR, RGB, okay, fine. If you are taking something else like adding another alpha parameter to it, make sure to pass that also. So that's pretty much how you're going to be applying your filter. But what I told you at the start of this video was that we're going to be playing with something called as a canny function. Now canny is a very cool function that is absolutely used for edge detection. Now edge detection in a simple image is okay, it's cool. But what if you apply an edge detection to a live video feed? And what happens is that you create this amazingly cool filter that's just having your edge only, and it's actually feeding it to your input image. So what I'm going to be doing now is create something called as an edge. And what is that going to do? It's just call the canny function, and the canny function is going to take the grayscale, and there's going to be two parameters that's going to be passed for this. One is going to be the 100, which is going to be the minimum threshold or minimum amount of data that I need to have, or the minimum value that needs to be there to form an edge. And I'm just keeping it as low as possible because it catches as many edges as possible. And the maximum threshold is when I need to stop understanding that that is not going to be an edge. So that's very simple application for canny. You can go inside and find it, or a lot of information that are available inside right here. So once you're done applying your edge detection, what do you need to do next? All you need to do is again replace your gray with edge, and edge, and nothing else is going to change because your input data is going to be gray, and the edge is going to be basically a filter on top of it. Think of it like a pre-processing layered pre-processing. All right, cool. Now it's done. Let's run this application. I'll also change the this to front facing camera. Your portrait and camera is going to be front facing. All right, this is I've changed here. I've changed it in my phone, and let's run this application. All right, so I am getting some data, but it is not as expected, right? It's okay. It's detecting as many edges as possible. As you can see that it's actually very crisp as well. It's detecting the edges possible. I have enough light on my face as well, and it's detecting it as much as possible. So now let's play around with this canny function. Alright, so I've done two quick changes to the input after we looked into the final output that's now there. What I've done is I'll try to convert it back to RGB, but still the color format is going to be luminescence, and I also modified the canny's input threshold and the threshold 1 and threshold 2. I've made it a 10 and 100 to see how much of the edge can be detected. So running the application after this, and you can see for yourself. Alright, this is frequent disconnections. You can find that it is much more easily able to find the edges, and that's pretty much how your edge detection works. You can play with your threshold, you can do as much as you want to, and you can apply cool and funky maybe filters on top of it, and that's pretty much how you do your entire you create an entire filter. So there's a lot of work to be done right on top of this. You can still use it, but if you want to, you can still play around with CV2 colors and even apply all top of filters on top of it, maybe even apply a contour and try to get some useful data, remove all the noise, and just apply on canny on top of it. So it's going to be it's actually a very interesting way of applying and finding and playing with CV2. But I just wanted to show you guys how this can be done on a real-time feed, and this is basically how you write your entire structure. So I'm going to be uploading this entire code to my GitHub repository. Check the link in the description. But before that, let's find a quick node of the sponsor and show you guys how the Embold.io static analysis tool works. Alright, so what I've done right now is once I've completed the entire building, I've actually now changed or pushed my code to this location. So this is going to be the GitHub repository, and it's going to have all the code right here. And I'm going to run the static analysis tool on top of it to see for any other recommendations or suggestions that I might have missed. So just go select your repository and add repositories at Embold, and it'll start running or scanning your entire repository. It definitely going to take some time, so we'll wait for that to complete, and you will see for yourself how clean and easily you can actually analyze your entire code. Alright folks, so the scanning is completed. It took about 17 minutes to scan my entire repository. If you look at the code that I pushed, it has primarily 3 main py files, and also I pushed the vn as well as part of the repository so that I could show you guys how this entire code repository static analysis tools work. So once the Embold finishes running your code, you can see it gives you an overall rating, and it does not mean that your code is bad. It's just for the final 8 KPIs that it finally scans it for. It checks your efficiency, and the efficiency is about your 100, it's almost 97%, and also functionality, maintainability, robustness, and you can see all of these parameters being used, and this KPI is being generated. And the most important ones is where you go into your code issues, and you can see for yourself all the different issues that it has found out in your program. And if you see here, it is automatically fixed up or found out as an issue that's about error building ASTNG representation. I do not really know what this issue is. So what I do is I just click on this, and you can find yourself a description. It says what are the things that it has found out that is actually having this kind of an issue, and it's also pointed that out right here. And the second important feature that I also like about Embold is its anti-pattern feature. Anti-pattern is something when you are doing some kind of over engineering, trying to do some good with the design pattern, but end up doing the opposite of it. So anti-pattern feature is actually very, very interesting. Again, here it is called out a data exposure, and you can go inside to see what exactly is the issue, and if you want, you can go and fix it. I cannot really fix it right now because it has checked this anti-pattern, or it has found an anti-pattern in the venv, which is like the Python's repository itself. So I'm not going to be able to do it. Alright, so when you go to the component section, this is also where you can find your issues by the overall rating. So I just give probably above 3, and you can just filter out all the things that are having the rating of above 3. And we are primarily concerned about the files that we wrote. So let's quickly check if that file is having any other issue. I can now quickly check what are the files that is having that issue with all these parameters right here. So you can filter it out, check it out, and it's pretty much what you're going to be doing if you're actually going to be maintaining a huge repository. Great tool. And thanks again for Embold for sponsoring us with this video. Let's go back and summarize this entire video. Thanks again for joining me on this KivyMD plus OpenCV integration tutorial. We learned about integrating a KivyMD slash OpenCV filter basically to process our image and render it as part of an KivyMD application. So this is going to be useful if you're building your own face filter applications and things like that, but also make sure that you understand that this is going to be a very CPU heavy process. So if you have a very poor CPU, your output might change, and that's also one important point that I want to add before I summarize this video. So that's pretty much what I wanted to share with you guys. Let me meet you guys in the next video with another interesting video on KivyMD and OpenCV series. Until then, Bharat, peace out, have a super awesome day.